let's learn Cauchy sequences. Let's look into the definition, which states that a sequence an is said to be a Cauchy sequence if for all epsilon greater than 0, there exists m belonging to n, which is the set of natural numbers such that mod of an minus m is less than epsilon whenever n is greater than or equal to m, which basically means that no matter which elements you pull out of a sequence, their difference should be less than epsilon. Which brings us to Cauchy's criterion for convergence, which states that a sequence is Cauchy if and only if it is convergent. Talking about convergence, we stumble upon the Cauchy's general principle of convergence, which tells us about a necessary and sufficient condition for a sequence an to be convergent is that, for all epsilon greater than 0, there exists m belonging to n such that mod of an plus p minus an is less than epsilon for all n greater than or equal to m, and p is greater than or equal to 0. Since now you know about the Cauchy's sequence, let's hop into some important theorems. So first, Cauchy's first theorem on limits, which states that when the limit as n tends to infinity an equals L, then limit as n tends to infinity, the mean of a1, a to up till a, and also equals L. Let's learn this by an example. Consider an equals 1 by n for all n equals 1, 2, 3, etc. Then as we know, limit of an as n tends to infinity is 0. Now, by the theorem, the mean of an approximates to around log with base e of n upon n, which then tends to 0 as n tends to infinity. Cauchy's second theorem for limits, let limit of an as n tends to infinity equals L, and an is greater than 0. Then limit of a1 plus a to plus an the whole raised to 1 by n as n tends to infinity equals L. A similar corollary we should be aware about is if an greater than 0, and limit of an plus 1 by an equals L, then limit of an raised to 1 by n as n tends to infinity also equals L. Let's understand it with an example. Consider the sequence an equals 2 raised to n for n equals 1, 2, 3, etc. Now we know that limit of 2 raised to n plus 1 by 2 raised to n as n tends to infinity equals 2. Now by applying the theorem just seen, we get limit of 2 raised to n the whole raised to 1 by n also equals 2. Thus the Cauchy's theorem holds. A homework for you guys is to find about the Cesar's theorem. Now, getting on with the easiest one of all, the sandwich theorem, which says if you have 3 sequences, in this case an, bn, cn, such that an is less than or equal to bn and bn is less than or equal to cn, and if limits of an and cn equals L, as n tends to infinity, then limit of bn is also L, as n tends to infinity. You guys can try and search for an example and make sure to write it in the comments. Let's look into some results. If a sequence, whose elements are greater than or equal to 0, and the limit of the sequence, an as n tends to infinity is L, then L is greater than or equal to 0. Now, let an and bn be two sequences, such that an is less than or equal to bn for all n belonging to the set of natural numbers, then limit of an is less than or equal to bn as n tends to infinity. Now, let an be a sequence of real numbers, such that the limit of n plus 1 upon an equals L, where mod of L is strictly less than 1, then limit of an as n tends to infinity equals 0. In the sense if L is less than 1, implies that an is greater than an plus 1. You can visualize it as mod of an decreases to 0 as n tends to infinity, as the successor element is lesser. The rest are obvious. Some more results, make sure to pause the screen and note the first one. The second one is obvious. Students note that if an squared tends to a as n tends to infinity, does not necessarily mean that an should tend to a. In essence, the mod sign, or as we say, an should be absolutely convergent to a as n tends to infinity, as it can even converge to minus a. Let's see some questions.
If you have answered all the questions, you have understood the topic. Happy learning!